We're looking at question 34 in the AP Statistics Midterm Review Packet, and I'm not going to read that prompt. I'm just going to look at what's given to me. It looks like it's a normal probability plot, and I'm going to go ahead and read what I'm being asked to find. Which of the following statements about the shape of this distribution, the shape of that normal probability plot, is true? I really don't need the context then, do I? If I look at my choices there, none of them involve the context. So what I'm going to do is I'm going to go ahead and draw in where my center is for that normal probability plot. So I'm going to draw a horizontal line where my z-score is 0. And I have labeled there, you can see on the left side that I have positive z-scores and I have negative z-scores where they're at. That's going to be a little helpful because the positives are on the top, the negatives are below. And if I look at that, I can see there's a curvature to it. And that's important to keep in mind, is there is a curve to our normal probability plot. Now, one thing to know about normal probability plots is that if it is normal, and look at choices A and B here. A says the distribution is normal. B says the distribution is approximately normal. And it's really important to keep that in mind because those are two different ways of saying it. And I'll just zoom in on that part. To be normal is, if I say normal, I mean perfectly, a perfect normal distribution. Now, a normal probability plot, a perfectly normal probability plot shows a perfect linear pattern. I mean, every point has the same rate of change, perfect linear pattern. An approximately normal distribution shows an approximately linear pattern. So that's something to keep in mind, is to say normal is different than to say approximately normal. That's a really good point to make on this multiple choice question, which can help you on free response. Don't say normal unless it is perfectly normal. You have to refer to it as approximately normal. So that allows me to go ahead and eliminate choices A and B. I have to then realize, how do I analyze this? And you've heard me say that it looks like above there's this curved part on that normal probability plot. And I'm going to also say it looks like it's stretched, doesn't it? I mean, it looks like I take it and I'm like pulling them and it's causing that curve. So if you think about what type of distribution, if you think about normal, just distributions themselves, not normal probability plots, but just shapes, if it's curved or stretched out in the positive direction, what do we know about that? And we know that means it's going to be skewed. Now, one thing that we can tell, by the way, and this is something to keep in mind, because this one's nice, choice E is skewed. None of the choices here specify direction, whether it's right skewed or left skewed. That's how you can build on this problem. Is I could say, instead of saying that it's skewed, I can make choice D, it's left skewed, and I can make choice E, it's right skewed. Then you have to know the difference between it when it comes to normal probability plot. And you have to realize this is being stretched out in the positive direction. So if you stretch a curve, so I have a curve, and if I decide to stretch it in the positive direction, you could see that's right skewed. So when I have the stretching on that positive z-score part, it's kind of like being stretched on the positive z-score part of the distribution. If the stretching was down in the negative z-score part, then that'd be like stretching when it comes to a negative. So I'd be going like here and it'd be stretched way out to that side and it would be left skewed or negative skewed. So it's good to go over this problem because you have the ability to analyze normal probability plots and determine, okay, is it left skewed, is it right skewed? And also, to say normal is different than to saying approximately normal. Don't say normal unless it's perfectly normal. Use approximately normal if you're not sure.